So welcome everybody to this latest video on 162 Maths. In this video we'll be doing another GCSE revision video going over an AQA topic test on the higher syllabus, this time based on scatter diagrams. Now there will be a copy of the questions in the description below for you to download and have an attempt at before watching this video and going through the answers. So let's get started on this scatter diagram topic test from AQA. So looking at question 1, it says match each scatter diagram with the description. The first one has been done for you, so all we need to do is draw a line, and the second diagram represents a weak positive correlation, so we join that one there, and the last diagram shows no correlation or little to no correlation, so we join it up with that. Moving on to question 2, it says here are 3 scatter graphs, and what do we need to do? We need to match up which scatter diagram with the correct response. So this one says which graph has the strongest correlation will be the one where all the points are closest to the line, and that's going to be graph B. It then says which line of best fit should not have been drawn. Well, that's going to be graph A, as it has no correlation. Key point is that you should never draw a line of best fit unless you can see some form of correlation, or the accuracy of that line of best fit is based on how strong the correlation is. So moving on to question 3, it says the scatter graph shows information about the results of 10 students in 2 tests. So question 3a says the data has strong positive correlation. Describe in words the relationship between the results of the first and second test. So basically something along the lines of, if you did well in the first test, you will do well in the second, and vice versa. So something along those lines. So for example, as the results in test 1 increases, so will the result in test 2. Something along those lines would be absolutely fine. Question 3b says that in the first test Hannah got 38%. Estimate her mean percentage in the second test. So all you need to do here is find 38 on the x-axis, or the bottom of the horizontal axis. So 38 is around about here. Now you want to physically draw a line on your diagram, or mark it on your diagram, and then once it hits your line of best fit, you kind of then want to kind of project across. It doesn't have to be in a different colour, but you're looking around about 26. So that's the answer we're going to write here, so around about 26%. Moving on to question 4, it says the scatter diagram shows information about advertising costs and revenue for a company. And question 1a says use the line of best fit to estimate the revenue of advertising costs of £600. So £600 is going to be way here, and so if we draw a vertical line from 0.6 as it's in thousands, so 600 equals 0.6 thousand, and then we just need to roll across, in which an acceptable answer, I would say, would be any answer between 18,000 and 18,500. So something along those lines would be adequate for your final answer. Then for question 4b, it says use the line of best fit to estimate the revenue of costs for 6,002, or you're spending 6,002 on advertising. So again, all we need to do here is find what's going. Each little box represents 100, 200, so 6,200 is going to be here. And so if we draw a line with a ruler preferably, and then as soon as it hits, you then want to kind of project horizontally, and I would say any answer between 40,500 to 41,000 would be absolutely fine for that. And then question 4c says which of these estimates is more reliable? Well, it's going to be your answer 4b, or for 6,200, as it falls within the range of data. Now, depending on how well you've been taught, this is basically what we call interpolation. And so as obviously the first value of 600 is extrapolation as it falls outside the tested range. So for example, if you look at all the points and the marks on the scatter diagram, the lowest amount was around about 1,200 and the most expensive was 11,000 spent on advertising. So any prediction made between 1,200 and 11,000 will be fine. However, anything outside of that is going to be a little bit more unreliable. So now let's have a look at question 5. It says that Adam wants to use an archery game at the school fair. He asks people to shoot arrows at a target from different distances. He obtains the following data. And again, so here we've got a set of data from distance from the target going along the bottom and the probability of hitting the target going along. So it says he wants to make 60% profit on what he charges players, use the line of best fit to work out how far he must put the target. Now, if he wants to make 60% profit, basically he wants the players, so 60% sort of a win for, what's his name, Adam, equals a 40% win for players. So in other words, you want a 40% profit. Now, 40% probability. So if we draw a line of best fit, and let's just go for something that looks like this. Now, obviously, depending on where your line of best fit falls between, and again, there will be like sort of boundaries in which you should be aiming for. Then once you've drawn your line of best fit, you then want to have a look at where 0.4 lies. And as soon as it hits the line, you then want to project downwards. And this value here is going to be your answer. So for me and mine, it's going to be around about 22.5 meters. And then finally, moving on to our last question, it says that Sarah cycles home from work each day. The scatter diagram shows the results of her journey time. So we've got the time that she leaves work and how long it takes. Now the question says the table shows one more set of times, and we just, for part A, we need to plot this coordinate. So we're looking at 517, which is just 2 squares off. So there. And the time it takes is going to be, I would say, around about 32. And then let's have a look. Hold on. So 51, take away 17 gives us an answer of 34. So what I need to do at this point is mark where 34 is, which is just there. And that there is my part A. Then for B, it then says Sarah leaves work at 5:12 p.m. Use the line of best fit to estimate the time Sarah will arrive home. So what we need to do now is actually draw a line of best fit. Now again, you want to try and be as accurate as possible. So let's just get that there. And yep, something along those lines. But and then from that, what we then need to do is find 512, which is here, and you just want to project upwards. So from 512, wherever your line of best fit is, like so, and I make it out to be around about 32 minutes. I just project across like so, and so I'm looking about 32 minutes. So then if I add 512 plus 32 minutes, I'm going to get final time of 5:44. And then for part C then says one day she works late and does not leave work until 6 p.m. Write down 2 reasons why the scatter diagram may not be useful to estimate what time she will arrive home. Now in terms of this, something along the lines of the fact that this is outside the range of tested times. And again, if you have been taught it, you could say it's extrapolation. And another thing is that at that time the traffic or road or driving conditions may be different. And so something along those lines in terms of the comment. So something that definitely, one of the reasons has to be the fact that the times falls outside the tested range. So if we go back, you can see that 6 o'clock is off the graph. And so it's not going to be able to use the scatter diagram to use that. And something along the lines of the fact that we only know what happens between the times of 4:45 and 5:30. We don't know that any times outside that data range. So again, something along the lines of that traffic or road or driving conditions may be different. So for example, it may be darker, maybe brighter. It might be obviously rush hour in terms of that, then people might be leaving work. So something along those lines will be absolutely fine to get those 2 marks. And that concludes the end of this test on scatter diagrams.